So my talk today is on the extreme scale scientific software stack, or E4S. And the main motivation for our talk is that as our software is getting more and more complex, it's now getting harder to install all our tools and libraries correctly in an integrated and interoperable software stack so that we can deploy our applications to high throughput computing platforms like OSG-HTC. Now, E4S provides a containerized platform that features a very capable HTC software stack with support for GPUs. And I want to explain exactly how we deploy this software, how you can use it on OSG-HTC. So E4S comes from the Exascale Computing Project that is building the largest supercomputers in the world. And you can learn more about ECP from our exascaleproject.org website. Now, ECP has three main focus areas: the application development, the software technology, where we have over 70 different software products, and then the hardware and integration, where we deploy to the DOE HPC facilities. And many of you may be familiar with our work. Until now, we used to have supercomputers with GPUs from only one vendor, NVIDIA. And this is true for Summit and Sierra and the previous generation of systems. But in the future, and now we are featuring Exascale systems with GPUs from three different vendors: Intel, AMD, and NVIDIA. So we need to build a software stack that includes all of our packages that support these three different GPU architectures. And we have Perlmutter running at Berkeley Lab. We have Frontier, which is now the #1 supercomputer on the top 500 list at Oak Ridge National Labs, and Aurora and LCAP are coming online. These feature Intel and AMD GPUs respectively. And our goal here is to build a comprehensive, coherent software stack that enables application developers to be highly productive and to leverage the massive on-node parallelism that we find in our nodes now. And E4S is a curated software portfolio. It is based on the SPAC package manager, and it supports multiple architectures with support for GPUs from NVIDIA, AMD, and Intel. And we have quarterly releases. We have a very aggressive release schedule, and E4S is available with completely source-based builds with on-prem installation, containers, cloud images, and even binary caches. You can see that from the first release in October 2018, where we had 24 products, now we have over 100 different HPC products, and we support areas like AI/ML with PyTorch, TensorFlow, co-design, and even electronic design automation with tools like Zeiss. So what is E4S? E4S is a community effort to provide open source software packages for developing, deploying, and running scientific applications. It has a comprehensive, coherent software stack, which includes over 100 HPC packages. We now have over 50 electronic design automation packages, and also AI/ML packages such as TensorFlow, PyTorch, and a whole slew of Python-based packages that are available with containerized deployments. Now, we have support for both bare metal as well as containerized deployments with support for GPU platforms. And we support x86-64, IBM's PPC64LE, ARM64 with support for GPUs from these vendors. And we have container images that are available for download from Docker Hub and the E4S webpage, where we have base container images that just contain the vendor runtime, as well as full-featured containers. And then we have commercial support through our partner organization, Paratools Inc., for support for installation, maintaining issue trackers, and also engagement with the applications. You can learn more about it on these web pages. We also have tools that allow us to use E4S containers effectively. We have E4S CL, which is a container launch tool that allows you to replace the MPI in your containerized application with the system MPI. So you could replace MVAPage with Intel MPI. You could use OpenMPI. you can have a mix and match of these different MPI flavors from the vendor and the research community. We have E4S ALC, a tool that allows you to create custom container images, starting with some base image or a full featured image. And we have quarterly releases. We also have AWS integration, and I'll speak a little bit more about that. But let's get into how you use E4S on the OSG-HTC systems. Now you can see over here that in the CVMFS file system in singularity.opensciencegrid.org, there is a ECP E4S containers directory. And these are the containers that we have currently. You can see the 23.05 images for CUDA and one API. And you can just use a workload.submit script, which you refer to the Singularity image. You can specify the GPU capability and then just specify the executable. Here, the test.sh is just running. I set the export CUDA visible devices to 0, 1, 2, 3, as many GPUs as you want to use. I'm running some Python tests. Here I'm using Python and getting the list of architectures where PyTorch is supported, LS CPU, NVIDIA SMI, and I just use Condor submit to submit this job. Here is the output. It runs on this PDX, on this OSG-HTC system. It says that the device name detected is RTX A5000. These are the architectures that PyTorch supports in this container image. SM35, 70, 75, 80, and even 90 for the H100 GPU. So you can see CUDA 12.1 supported with all these visible GPUs and the LS CPU output. Here is an example of the extensive list of Python libraries that are available. I can just say Python, import NumPy, SciPy, Matplotlib, TensorFlow. These are the versions of TensorFlow, 2.12 or PyTorch 2.0, and it's showing the H100 GPU available. This is E4S 2305 containers on Expanse at SDSC, where I can just get a compute node with a GPU, and then I can go to this directory where we have the E4S 23.05 installation, and I can look at this module load Singularity Pro, run this with the --nv, and even look at all the packages in the dist packages directory and load all the Python-based tools. You can also pip install in your own space. So you can use these images as starting points. E4S also includes, besides Python, it includes Julia with support for CUDA and MPI in our images. Those who are exploring Julia, you can run a workflow like this. This is showing you a hello world program with MPI. You can use CUDA with this as well on the 23.02 images. We are also deploying to the cloud platforms. In fact, we are trying to use E4S on all the cloud platforms, not just AWS. And there are many issues, including issues with MPI, where we need low latency, high bandwidth. So using tools like MVAP-H2 helps us address those issues with support for Elastic Fabric Adapter. If you are trying to start on AWS, you'll see that if you start with just a base Ubuntu image, there is too steep a learning curve. Instead, you can start with an E4S image, which will help you in building and running your applications. Provisioning the AWS images from the command line can be cumbersome. We also have support for using ODDC from adaptive computing, and they can use a web interface to submit the jobs. In MPI, you must pick the right MPI and then schedule it with the, interface it with the job scheduling package, and make sure that you have efficient inter-node communication with the network adapters. And intra-node communication is also important. So you need the XPMEM drivers and GPU direct async support for communication between GPUs. So we are using E4S to address all of these issues, and we are building an optimized MVAP-H+ based solution which targets multiple cloud providers and uses ODDC to launch these jobs across different cloud providers through a web-based interface. You can also burst to the cloud using E4S. You can burst using Moab scheduler. And this is the E4S image, which has a remote desktop based on DCV on AWS. And you can see many packages which have GUI front ends that are available here. This is for electronic design automation, EDA tools, and there's 50 different EDA tools that are available. Here's a listing. You can see tools like Xscheme, K-Layout, Qflow, and this is OpenRoad, where we are looking at Microwatt, an open source chip that is open source from Open Power Foundation from IBM. And you can see all the connections in this IC in OpenRoad GUI. Here's a list of 50 different packages that are available in AWS for E4S, those who are looking at EDA. And it all depends on the SPAC package manager. SPAC allows you to build different versions of the packages, and you can just git clone the SPAC repo, source the setup script, and install a package. You can say SPAC install tau, for example, and it will install tau. I also recommend looking at the SPAC compiler find to find the system compilers and external find. And this is all there within the container. So you don't have to install anything. The containerized distribution includes all these packages. You can say install tau version 2.32 with this @ symbol, using the GCC compiler 9.30 with this % symbol, or even the variants, like you can say plus ROCm to use AMD GPUs, or plus MPI with MVAPIC2 version 2.3. So these are the specs that are available. There are over 7,000 packages available in SPAC. And it's a mature package manager. You may want to visit the spac.io webpage to learn more. And using SPAC, we have created containers. Containers that are now available for download from the E4S.io webpage. And these are containers that are released every quarter. And you can see that we have support for CUDA with different architectures. We have made compact images, one for each architecture. So there's an image for A100s or H100s or MI100 or MI250X for different GPUs, for different processor architectures, and there are over 100 different products. We have full-featured images for AMD, NVIDIA, and Intel GPUs. You can use Docker pull or Singularity images from our webpage. These are full-featured images with over 100 different packages. We now have the ability to distribute Intel compilers and Intel MPI as part of our E4S images. Yes, let me repeat that. We are allowed to redistribute Intel tools from E4S with a special redistribution agreement with Intel. And we thank them for allowing us to do this with E4S. So we have this agreement that brings Intel in line with E4S builds that include AMD and NVIDIA tools as well through a partnership with Paratools Inc. And you can get base images like this 23.05 API images, which includes base kit as well as HPC toolkit from Intel. And we have minimal SPAC images, all Singularity images. And we have even a tool called E4S ALC, an a la carte tool where you can say, start with this base image, add these packages to it. Some of these packages are through SPAC or operating system, Yum, or apt or zipper installs, and even expand a tarball in this directory. So you can create a JSON file where you describe that install Cocos and Raja from SPAC and NeoVim and Valgrind from the OS packages, and specify an initial image and a final image, and it will do that for you. So you no longer need to learn how to write Docker files or Singularity files. You can just use a command line tool to create custom container images. And then these images can be deployed on OSG-HTC. So we have DOE LLVM images, continuous integration images. It's a large project. We have support for bare metal installation with detailed documentation. You can see these images on Docker Hub as well as our E4S.io multi-platform images. And you can see the base images over here. And even the minimal images, you can see that we have over 1 million downloads. So these have been adopted broadly by the Linux community. And in case you're wondering, what are these 100 packages that we have? These are the packages that you already know and use. These may be packages like HDF5, packages like Cocos, Raja, packages like OpenMPI, MPitch, Parsec, ParaView, Tau performance system, or Trilinos, or PETC. And you can see the full list of over 100 different packages. It includes 3D visualization tools. Here is one API and the compilers and what packages are built, and AMD tools and how to use it with AMD GPUs, LLVM for different platforms. We have a build cache with over 100,000 binaries, so you don't need to recompile from source code, and even a tool to simplify the launch of MPI jobs, where you can say, I want to use Singularity. Here is the container image. Start up with using this source.sh, which can have a Singularity with a stack setup and loading a module. And then you can just say E4SCL MPI run on the application, and it will replace the MPI in the containerized application with the system MPI. So you can get efficient internode communication performance, and you can distribute your applications for the first time in a binary form, not as a source tarball. Now, E4S is a container platform for high throughput computing. Our containers supporting both NVIDIA GPUs and Intel runtimes are now available on OSG-HTC. You can just see this directory. It has the CUDA 1 API latest Singularity containers. We have vendor runtimes from CUDA as well as NVHPC as well as Intel 1 API. We feature TensorFlow, PyTorch with a number of Python packages. You can see this. You can pip install other packages. You have 100 different HPC tools as well as base containers and full-featured containers and tools to customize these. And E4S containers will continue to be supported in future releases on the Open Science Grid, and it will provide a viable platform for tool integration for HTC. With this, I would like to thank the ECP project, and I'll take on any questions